Uh, Very good morning to everyone. Regarding fundamental data structure, I explained about up to sparse graph in the previous video. So the remaining things I am going to continue within this. Dense. Dense means a graph with relatively few possible edges or missing is called as dense, which means that we cannot guarantee that all the vertices will be connected by the edge, because it sometimes let me assume that 1 2 3, there are three vertices 1 2 3, one is connected with 2, 2 is connected with 3, but 1 and 3 are not connected with each other. This is called as dense because some edges are missing. So now 1 and 3 connectivity is missing, so this is called as dense. Next one is graph representation. So we will represent the graph in two different way. One is adjacency matrix and another one is adjacency list. Adjacency matrix means in a graph, in a given graph, whenever there is a connection or edge exists between the two vertices, then in the matrix it will be represented as 1. If there are four vertices are available, then 4 by 4 matrix will be represented. 2 vertices are available means 2 by 2 matrices will be represented. Likewise, n number of vertices means n by n matrices will be represented. So n by n adjacency matrix will be represented. So let me assume that one graph which has three vertices means let it be 1 2 3. So in rows 1 2 3, column also I have to write 1 2 3. If there is a connection between, if there is an edge between 1 and 2, then I have 1 comma 1 I have to put 0, 1 comma 2 I have to put 1, then 1 comma 3 if there is any edge exists I need to put 1, otherwise I need to represent it by 0. And adjacency list means based on the adjacency matrix only the adjacency list will be created. Here the adjacency matrix occupies more space compared with the adjacency list. So adjacency list is the best representation of graph. So this is the definition for adjacency matrix. Let G is equal to V of E, vertices and edges, be a simple graph where V is the vertices and E is the edges, N be the number of vertices in the graph. The matrix is defined as A of ij equal to 1 if there is an edge from vertex I to j, otherwise 0. So adjacency list means, as I said before, it is a graph collection of linked list, one for each vertex that contains all the vertices adjacent to the list with vertex. And best graph representation, I told you that adjacency list is the best because adjacency matrix occupies more space. Next one is weighted graph. If I assign any value over the edge, that is called as weight for the graph. For example, 1 2 3 is the vertices. 1 and 2 are connected by an edge with weight 1 means the weight for the corresponding edge is 1. So the weight graph is a graph with numbers assigned to its edges. These numbers are called weights of an edges. Then paths and cycles. There are two important properties. One is connectivity and second one is acyclicity. A path from vertex U to vertex V of a graph, that is G is equal to V comma E, it can be defined as sequence of adjacent vertices that starts with I and ends with V. For example, 1 2 3 4, 1 and 2 are connected means it will be represented within bracket 1 comma 2. 2 and 3 are connected means 2 comma 3. 3 and 4 are connected means 3 comma 4. 4 and 1 are connected means 1 comma 4. So 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 1. So each and every pair has to be represented within a bracket. That is called as connectivity. And acyclic cycle means a cycle is a path of positive length that starts and ends at the same vertex and does not traverse the same edge more than once. So there is no direction between the vertices over the edge. Assume that A or number 1 is a starting vertex, 2 is the next vertex, 3 is another, 4 is another. Then 1 will be connected with 2, 2 will be connected with 3, 3 will be connected with 4, again 4 will be connected with 1. So it will look like a cycle. So starting at 1 and ending at 1. So both start point and end point are equal. So this is called a cycle. Next we are discussing about trees. Tree is a connected acyclic graph. I think you might have learned well known about trees in your data structure. So it is also a data structure, kind of a data structure which is used to represent the flow of data. Trees has several important properties other than graph, that is modulus of E is equal to modulus of V minus 1. Next one is rooted tree. The trees are usually expressed in the form of rooted trees. When a tree has to be represented in the form of rooted tree means select an arbitrary node, that is called as root node. The vertices are adjacent to the root. The root will be called it as level 0 and the child nodes are called as level 1. Child means a leaf node. The bottom of the tree will be called it as the child node which has no children. That is also called as leaf node. So a node with in degree 0 is called as the root node. And if u comma v is the last edge of the simple path from the root to vertex, then v is not equal to v. That is simple vertex u is not equal to v. Then it is said to be the parent of v. Parent of v means, I will tell you one real life example. Our grandparent is the parent of our parent and our parent is the parent of us. So we are the child. If we have anything, then it will be called as children node. So next one is siblings. Siblings means two different nodes have the same parent, that is called as siblings. Like our brothers and sisters are the siblings. Leaf node means a node which does not have any child, that is called as leaf node. Ancestor means our parent is an ancestor, child is a descendant. So in case of ancestor, a root node will be the ancestor and a descendant, all the child node will be considered as a descendant. Then depth, level, height. The depth of vertex V is the length of the simple path from the root to V. So here V is the child node and the path from the root node to the child node is called as the depth. Number of edges in the path from root node is called as the level. Height of the tree is the length of the longest simple path from the root to a leaf. That is, we might have so many paths from the root to leaf. So we have to identify the longest path from the root to leaf is called as the height. Next one is binary tree. A binary tree at most have two child. Then only it is called as binary tree. That is a parent node with left child and right child. Left child has this minimum number, right child has the maximum number when we compare with the root node. The subtree with its root at the left or right child of the vertex is called as left subtree or right subtree. Strictly binary tree means out degree of every node in the tree is either 0 or 2, then the tree is called as strictly binary tree. Out degree means the leaf from the node is called as out degree. And a strictly binary tree in which the number of nodes at any level is 2 to the power of minus I minus 1, then the tree is complete binary tree. Next we are going to discuss about sets and dictionaries. Set means collection of distinct element, and each and we will represent anything in terms of set. For set of student in a class, set of books in the library, set of records for a particular laboratory class. So we can represent sets for any other thing, and we will perform union and intersection operations, and so many operations are associated with set. Union means if two different sets are available, one set is A, another set is B, means A union B is equal to collection of both the sets. That is, we have to write all the records from all the elements from the A set combined with all the elements from the B set. And intersection means we have to choose the common element. The data structure that implements these three operations is called as dictionary. Dictionary means either we can perform insertion or deletion, or we will search some element from the set. This is called as dictionary. So within this, first module is over. So thank you everyone.